Now that we've looked at graphing linear equations, we're going to shift over to inequalities. So what is an inequality? A linear inequality is a linear equation that uses one of the four inequality symbols: less than, greater than, less than or equal to, greater than or equal to, instead of an equal sign. So if we have an equal sign, it's an equation because it's equal. An inequality is when it's something other than an equal sign. The solution to our inequality is a set of points found in the shaded region, right? So if you think back to when we did inequalities before, we would always have something, oops, that's too big. We would always have something like x is greater than 1, and we would graph it on a number line. We'd go to 1, and if it was just greater than or just less than, we put an open circle, right? And then we would shade whichever way our arrow was pointing, or if all the x's that are bigger than 1 would be to the right. And then if it was like m is less than or equal to 2, we would draw a number line, put a 2 on there, and then I would use a closed circle because I'm including the 2. And then I would shade for this one everything to the left. It's very similar to that with an inequality, but now that we're looking at linear, we're going to have to graph lines somewhere and then do some different kind of shading. So if it's in slope-intercept form, the first thing you do is you look at your equation, or you write it in slope-intercept form. Then you graph it using your y-intercept and the slope, just like we've been doing for our equations. Then you connect the points according to the inequality symbol. So remember, before, this greater than or less than was an open circle, and then or equal to made it a closed circle. Well, now we don't have circles, we have lines. So the way that we're going to do an open circle is by doing a dotted line. So instead of having a normal line, it's just going to be dotted, right? So we're seeing where the line is, but we're not including it in our solution. Or equal to would just be a solid line. Right? And then that is just a solid line like we've been doing. And then you shade. So before we would do the arrow or the circle, and then we would shade one way or another. Well, now we're going to be shading on half of our graph. So either above the line, below the line, top left, whatever, depending on our equation. So I'm going to graph these in slope-intercept form. So to graph it, we're kind of going to ignore the inequality sign for right now. Treat this like y equals negative 1/2 x plus 2. I'm going to go to my y-intercept at 2. And my slope is negative 1/2. So that means I'm going downhill. So I can go up 1, left 2, or down 1, right 2. Alright? And you know I'm weird. I like to fill in my graph. All you really need is 2 points. So there's my the general idea of where my line is going to be. It's less than, which means I'm going to just use a dotted line. So instead of connecting it with a solid line, I'm just going to do a dotted line. Alright, and now I got to decide where to shade. If it's in slope-intercept form, right, where y is by itself, only if y is by itself, I can go with what the sign is saying. So I want the y's that are less than. Well, less than is going to be on the bottom, right? So if this is my y-axis, my y's get smaller as we go down and bigger as we go up. So if I want the smaller y's, because I want all the y's that are less than this line, I'm just going to shade down. So if it's in slope-intercept form, and you have y by itself, if it's less than, you shade below the line, greater than, you shade above the line. Okay, but y has to be by itself. So over here, I'm going to treat this like y equals 3x minus 2. So I'm going to go to negative 2 on my y-axis. There's my intercept. Positive 3 means I'm going to have an uphill slope. So I'm going to go up 3, right 1. Up 3, right 1. Or down 3, left 1. Down 3, left 1. Okay, or equal to means I have a solid line if I can connect my points. And y is by itself, so I want all the y's that are bigger. Greater than means I shade above. If you have an inequality that's in standard form, Okay, we're kind of skipping over point slope because point slope we can very easily make it slope-intercept form by just adding over that other y value. But standard form, you don't have to change it. We can still graph it in standard form. You're going to graph using your x and y intercepts, right, covering up each one to find your intercepts like we've been doing, and then connect according to the symbol. Just like before, if it's just greater than or less than, you have a dotted line, and if it's or equal to, we have our solid line. So that's still the same. Then, because y is not by itself, I can't go just based on what the inequality symbol is. I can't say that greater than means shade above, right? Because now x and y is on the same side. So all we're going to do is plug in a point. If it's a true statement, when you plug it in, you shade on that side. If it's false, you shade on the other side. Okay, the easiest point to plug in is 0, 0, because anything times 0 is 0, right? If by chance 0, 0 is on the line, it's not a good point to plug in, so you just have to pick something else. And then, based on if it's true or false, you shade. So, for example, this first one, even though it's technically not standard form, we're still going to graph it the same way, right? That negative a means it's not standard form, but that's okay. So, if I imagine covering up my x and solving for the y, right? 3y greater than 6 means that my y-intercept is at 2. Right? Then I can do the same thing for x, cover up my y, negative 2x equals 6, so my x-intercept is at negative 3. When you're first graphing, don't worry about the inequality sign. Treat it like an equation. So I'm going to go my y-intercept to 2, my x-intercept is at negative 3, and it's just greater than, so I'm going to use a, I'm going to use a dotted line. Maybe. Very crooked dotted line, but there's my dotted line. Now to decide where to shade. Okay, I cannot go based on this. The only time I can go based on my sign is if y is by itself. So I'm just going to plug in 0, 0. If I plug in 0, negative 2 times 0 is 0. 3 times 0 is 0. Right? 0 plus 0 is 0. 0 is not greater than 6. Right? So if I plug in 0, 0, I get a false statement. So 0, 0 is right here on my graph. That is not a solution because it does not fit my inequality. So because that's not a solution, I'm going to shade on the other side of the line. For number 2, 10x minus 5y equals 10. So if I cover up my x, negative 5y equals 10 means that my y-intercept is at negative 2. Cover up my y, 10x equals 10 means my x-intercept is at 1. So I'm going to go negative 2 on my y-axis, 1 on my x. It's or equal to, so I'm going to draw a solid line. And now I'm going to plug in 0, 0 to see where I shade. Alright, so 10 times 0 is 0. Negative 5 times 0 is 0. Alright, again, 0 is not greater than or equal to 10. So it's another false statement. Alright, 0, 0 is on this side of my line. It's not a solution. So I'm going to shade on the other side of my line. And then we're going to look at graphing horizontal and vertical lines. Okay, nothing changes. We're going to graph it the same way. So y is less than 3. That's a horizontal line, so I'm going to go to positive 3 on my y-axis, draw my line. Now it's just less than, so it's going to be a solid line. And I want all the y's that are less than. So y is by itself, so I'm going to shade on the bottom. I want all the y's on the bottom. Smaller y's go down. X is greater than or equal to negative 2. That's a vertical line, so I'm going to go to negative 2 on my x-axis. It's or equal to, so this one's a solid, really crooked solid line. Right, and I want all the x's that are bigger than negative 2. Well, my bigger x's are to the right, so I'm going to shade on the right-hand side. And that's all we have to do for inequalities. So you graph it like normal. You ignore your inequality symbol until you've already got it graphed, and then you decide whether it's a solid or a dotted, and then you got to pick which side you shade on.